enjoyed myself so much that I ran out of time. So that's the final step. I nearly made it. I wasn't looking at my clock there. So yeah, very final step was just to carry over the LN390, and that's sheet done. So like I said, you didn't have to take natural log. You could take any log you like. The point was, by taking a log, we can move this down. If you've done E, it will cancel out, but this just allowed us to move the K down. So that's all of those covered. So yeah, I think that's most of the major log things covered. That was the growth and decay. That was our graphs, and we looked at our log functions as well. I thought there was a few other ones there that I missed out. Let's see, are there any worth doing? Oh, you know what? I will have to do a separate way. I'll do a wee extra video for them. We'll miss them. Anyway, do a few more of them. This is the last thing, and it's not really logs. It's more to do with graphs, which we actually covered in other videos. But I'll just kind of quickly go through a little bit of this. Just one video. I don't want to spend too much time on it because it's similar, like I said, to the rearranging you do in the other one. So, sketch the curve, 1 take away log 3x. Right, so when I do this, I always think to myself, pad in the right place. I always think, right, what are my x and y's that I've got? What can I see? Okay. So I know that I've got this value, which is 1, 0. So I know I've got x is 1 when y is 0. And I've got this value, so I know x is 3 when y is 1. So that's my first thing. And then I'm going to look at my equation and say, okay, well, what's happening? So that is y equal to, and I'm going to write it this way, negative 1 log 3x plus 1. Now, whatever happens inside here next to the x, that's going to affect the x movement. Anything that happens outside of that, so what happens here and here, if there's a number here and here, that's going to affect my y. Okay, so anything next to the x affects the x, and you do the opposite. So if it says 2x, you would halve your x's. And everything that's outside affects the y, and you just do it as is. So what's happening to my y value here? Well, my y value has been multiplied by negative 1 and then adding 1. Okay, so I would come up with a little, a new set of equations and say I've got x and y. So what's happening to my x is absolutely nothing, they're just staying the same. But what's happening to my y value as well? I'm multiplying them by negative. Okay, so negative 0, add 1, that's going to become a 1. That's going to become negative 1 plus the 1 will give me a 0 in there. So how's that going to look? Let's see. So x is 1 and y is 1. That's going to come up to here. And the other one, x is 3 and y is 0. That's going to be over there. Now we should know, but again, it doesn't really matter. This graph here would be the negative log graph, yeah? So that makes all of our, y values negative, flips them round. If you're the negative x, it would go the other way. It would look something like this. Okay, looks quite nice, doesn't it? So that's a negative, and then we're moving it up 1. So you can see why it's going to do something like that. Okay. I will just check the answer. There we go. Boom. So, and then sorry, make sure you draw in the coordinates. Sorry, don't forget that when you're drawing your sketch. But the main point with this is very similar to the graphs and functions. The rule you want to learn, like if you know and you can visualize it, that's excellent. But the rule you really want to know is anything here changes the x values, and you do the opposite. So if that was a half x, times your x's by 2. Anything here affects the y's, and we do, just like BODMAS, we do the multiply and then the add. Yeah. So if that's negative 2, times them by negative 2, then add 1. Okay. So I think once you get that, it's not too tricky. You don't have to worry about how is it really going to look. You can apply your rules, draw your points, and then when you join the dots, you'll get the right idea. So I hope that's helpful. And the next one, determine the exact value of the x-coordinate of the point of intersection of the two curves. That's quite an interesting little question. That's quite good. So for that, let's try and zoom out a tiny bit. Let's see, well, point of intersection is where two things meet, isn't it? So I've got y is equal to log 3x. It's where they meet, it's where the y values are the same. And I've got y is equal to 1 take away log 3x, yeah? Okay. So if they're meeting each other, the y's have to be the same. So log 3x has to equal 1 take away log 3x. Makes sense to me. So if I rearrange that, I'm going to have to add that to the other side. So I'm going to end up with 2 log 3x is equal to 1. And then laws of logs, that's the same as log 3x squared is equal to 1. So that's saying then that x squared, or x squared, is equal to 3 to the power of 1. So x squared is equal to 3, so x is going to be root 3. There we go, x is root 3. And if you wanted the y value, you would just substitute that back in. But that would be tricky. So yeah, quite a nice little question that, just to remind you of what it means when you've got two things that, when they meet. So when you see intersection, you should be thinking, put them equal to each other. Obviously, you can do simultaneous equations as well. For these, I think it makes more sense. So a bit of laws and logs in there as well. So that's us. I will go back and do a few more log things to add in, because I just realised I forgot the last couple of questions. But I hope that was really helpful. You've got your growth and decay, you've got your graphs, and you've got your rules. And again, look at all these marks, 3, 4, 5 marks. It's an excellent topic. And I think that really is most of your skills. That you're not going to go far wrong if you've got all that. So yeah, good luck with it. And I would try and go with the logs. I know it looks odd, and it's not a natural way of thinking, but there's some really good marks to be had. So yeah, hope that's helpful.